Now, we talked about position, velocity, and acceleration. And let's do another problem using the concept of position, velocity, and acceleration. For a freely falling object, the position function is given by y of t equal to negative 5t squared plus v0t plus y0. That means the position at any given time is given by this equation. v0 is the initial velocity, y0 is the initial position. Alright, if v0 is the velocity when t equal to 0, that's the initial velocity, and y0 is the position when t equal to 0, where you start. A ball is thrown straight down from the top of a 220-meter building. So if you go to the top of a 220-meter building and throw a ball straight down, it means y0, the initial y value, y0 is 220 meters. That's the meaning there. Initial velocity of negative 20 meters per second. You see, something that is thrown down has a negative value. That means v0 is negative 20 meters per second. Write down the position function for the ball. To write down the position function, what all we need to do is replace the values of y0 and v0 that is given there. What is the velocity after 3 seconds? What is the velocity after falling 200 meters? Alright, this is the tower, which is 220 meters, and here's the monkey who is up there and going to throw the ball down with a velocity of negative 20 meters per second. I don't think he's going to do that, but we assume that he will do that. Okay, now this distance is 220 meters. That means initially the position of the ball is 220 meters above ground. We will take the origin as the ground. So we say the initial velocity v0 is negative 20 meters per second. The ball is thrown down with that velocity. The initial position y0 is 220 meters, and therefore the position function is y of t is negative 5t squared minus 20t plus 220. This is the position function. Well, if this is the position function, can you find the velocity function? Velocity function is the derivative of the position function y prime of t. I want you to practice these notations. Or dv by dt, or y prime of t. Now, y prime of t is the derivative of this. Find the derivative of each term. Negative 5t squared. The derivative is negative 10t. The derivative of negative 20t is negative 20. And the derivative of 220 is 0. So the velocity function is y prime t, which is negative 10t minus 20. Now we want to find the velocity at the end of 3 seconds. So what all we need to do is replace t by 3 seconds. We want v of 3. So v of 3 is negative 10 times 3 minus 20. That is negative 50 meters per second. Now let's talk about the third part. What is the velocity after falling 200 meters? The ball is dropped from a height of 220 meters. It falls all the way after falling 200 meters. It is here. What we need to do is, we need to find the time from this equation. We need to find the time when its position, this y of t, is how much? If it falls through 200 meters, its position is now 20 meters above the ground. That's the strategy we're going to use. So what is the velocity after falling 200 meters? First, we find the time taken by the ball to fall 200 meter. Now when the ball falls 200 meter, where is it? It is somewhere here. Now after falling 200 meter, its position is 200 minus, it has fallen through 200 meter. That means it is now at a height of, this is the position now, which is 20 meter. That's right. So it is now at a position 20 meter. That means in this equation, if you replace y by 20, we know v0, we know y0, then solve for t. We got 20 equal to negative 5t squared minus 20t plus 220. Now if you now solve this equation for t, that will give you the time for the ball to be at y equal to 20. That means the time taken by the ball to fall through 200 meter. All right, solve that equation, which will be 5t squared plus 20t minus 200 equal to 0. I'm going to leave it for you to solve it on your own. You can actually solve it on the calculator. It gives you a positive value and a negative value. Well, the negative value is not acceptable for a time. Therefore, we take the positive value. So that gives t equal to 4.6 seconds. In other words, the time taken by the ball to fall through 200 meter is 4.6 seconds. Therefore, the question we need to answer, what is the velocity after falling 200 meter, is the same as what is the velocity at the end of 4.6 seconds. So since we know v of t is negative 10t minus 20, v of 4.6 is negative 10 times 4.6 minus 20, that is negative 66 meter per second. All right, okay. We will now look at some of the important properties of derivatives. Now that's very important. I want you to pay special attention to that and learn some of the properties of derivatives. For that, let's start by looking at the graph of a function. Here you have a function graph that is, I say, concave down, is curving down. You can have concave down or concave up graphs. Here you have the graph of the function concave down. Its shape is concave down. Now, a tangent drawn at x equal to negative 2. Well, what I'm doing here is just approximate, just for the sake of explanation. So if I draw a tangent at x equal to negative 2, there you are. Its slope is approximately 2. If I measure the slope, how do you measure the slope? Go one step forward, and see how much you got to rise. If I go one step forward, I got to rise almost 2 to reach the graph. That means the slope of the tangent line at x equal to negative 2 is approximately 2. You notice that the slope of this tangent line is positive. How do you know if the slope of a graph is positive or negative? If the tangent line is sloping up like this, it's an increasing function. Its slope is positive. If the tangent line is decreasing, its slope is negative. So here, at x equal to negative 2, this tangent line has a positive slope, approximately 2. Remember, slope of the tangent line is a measure of the derivative at that point. So it means at this point, the function is increasing at the rate of 2 per second, or 2, whatever the input value we use. Alright, so we say f prime of negative 2 equal to 2. The derivative of the function at x equal to negative 2 is 2. That's the meaning that the slope of the tangent line is 2. Alright, let's now draw a tangent line at x equal to 0. There is the tangent line at x equal to 0. What is the approximate slope of this graph? If I go 1 unit to the right, I just rise 1 unit to reach there. It looks like the slope is approximately 1. That means the derivative of the function at x equal to 0 is approximately 1. We say f prime of 0 is 1. Tell me, what is happening to the derivative as we move from left to right? The derivative at x equal to -2 is 2. Derivative at x equal to 0 is 1. The derivative is decreasing. Alright, let's find the derivative, the slope of the tangent line at x equal to 0. Let's draw a tangent line at x equal to 0. You see, it's a horizontal line. What is the slope of that line? The slope of that line is 0. So we say f prime of 2, that means that is corresponding to x equal to 2. The derivative of the function at x equal to 2 is 0. So the derivative is steadily decreasing. Alright, let's do another one. At x equal to 3, I have drawn a tangent line. Can you see that tangent line here? It's rather difficult for you to see, I think. Now, the slope of that is approximately -1. Now, look at that slope, 2, 1, 0, -1. The slope is steadily decreasing. And if you draw the tangent line at x equal to 5, that will give you the slope is -3. Now, what do you see here? If the graph of a function is concave down, it means the derivative of the function decreases as we go from left to right. The derivative is continuously decreasing. So as x increases from -2 to 5, the derivative f prime x steadily decreases. So whenever the derivative of a function decreases, in that interval, the function graph will be concave down. Very important property. So where the function graph is concave down, in the interval where the function graph is concave down, the derivative of that function will be steadily decreasing. That's right. If the graph of f of x is concave down, then f prime x starts at a relatively large positive value and then continuously decreases. Now this needs to be understood in many ways. Now I can state it in two different ways. One, if the graph of a function is concave down, then its derivative will be continuously decreasing. That's right. That is the most important information that you will need to understand. If the graph of f of x is concave down, then f prime x starts at a relatively large positive value and then continuously decreases. On the other hand, let's look at the graph of a function that is concave up, is curving up. Now look at the derivatives at different positions. The derivative at x equal to -2. Now, what can you say about the derivative at x equal to -2 of this function? This is -2. And the derivative at x equal to 1 is -1. Tell me, which is greater, -2 or -1? -1 is greater. And the derivative at x equal to 3 is 2. So, if you go from left to right, in this case, the derivative steadily increases. So, if the graph of f of x is concave up, the derivative starts at a relatively low negative value and continuously increases. -2, -1, 2, 1, 2, and so on. Very important relation. If the graph of a function is concave up, in that interval, the derivative of that function will be decreasing.